Hello, everyone. Good morning, good afternoon, and good evening. Dear authors and invited guests, welcome to the technical session 9C. Myself, Anshika Jain, and this session would be moderated by me. I, on the behalf of Global Knowledge Research Foundation and GI Scholastic LLP, it is my great pleasure to welcome you to the Third World Conference on Information Systems for Business Management, ISBM 2024, Bangkok, Thailand. The third edition of the conference is being organized in the hybrid mode. The physical event was organized yesterday in Bangkok, Thailand, and the virtual event is being held through Zoom yesterday and today, that is 12th and 13th September 2024. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 6 presentations, and each presenter would be given 12 minutes for the presentation and 3 minutes for the questions and answers. On 10 minutes, I will raise a very gentle reminder. There is another request to all the participants that you stay connected with us till the closing remarks. If you have any query or any update, then you can write it to me in the chat box below. Just before we get started with the session, I would like to introduce you to the chair of this session, Dr. Sunil Kumar Jhangan, Senior Manager, Projects and Process, Visflux Plymed Limited, Jaipur, India. Sir currently serves as a Senior Manager, Projects and Process as Visflux Private Limited, Jaipur. In his role, he manages a cross-functional team overseeing the planning, execution, and delivery of projects across various domains, including tech, manufacturing, hospitality, and disaster management. His expertise in project management and Scrum methodology drives innovative programs development, while his research contributions continue to enrich the academic and professional communities. His research interests encompasses applications of machine learning and deep learning in real-life world scenarios, network security, and routing protocols for ad hoc networks. Welcome to the session, sir. Would you like to share a quick opening remark with us?
Thank you, Anshika, for this introduction. Highly obliged. And I wish all the best for all the presenter. Let's have a fruitful discussion in presentations. All the
Thank you so
best.
much, sir. So we will be beginning with the first presentation. First up, we have DK Chaturvedi to present his paper titled An Efficient Approach for Assessing Foot Using Advanced Image Processing and Computer Vision Techniques for Dimension Estimation. Are you there, sir? Are you there, sir? So we'll be moving on to the next presentation. Next up, we have Rehanuma to present her paper titled An Indicative Metric-Based Context-Sensitive Approach to Autocorrect Bangla Spelling. Are you there, ma'am?
Hello, yes, I'm here.
Yes, ma'am, you're audible. You may begin your presentation.
Okay. Thank you so much for giving me the opportunity today to present my work here in your conference. So I am Rahnuma Islam from Bangladesh, Daffodil International University. And the paper I will be presenting today is titled as An Indicative Metric-Based Context-Sensitive Approach to Autocorrect Bangla Spelling. This is the information of the authors of this paper. The first one is me, and the others are my colleagues who have worked with me on this paper. So in this paper, we will be discussing firstly the problem we have identified and worked on. Then this is actually a second version of another work. It is actually an improvement of another work we have done previously. So I will give a short summary of our previous work just for the knowledge. Then I will discuss the improvements that we made to this work and how the experimentations were done, then the results, and I will, after that, close my presentation. Thank you. So for our work, it is the work here mostly focuses on the spelling error detection and correction of Bangla language. Well, it focuses on the typing errors, mainly the non-word errors. That means spelling errors that occur due to slip of hand, fingers, or mistakes made while typing electronic materials, which are also named as typographical errors. In such cases, the spelling of the intended word is incorrect, and the error word also does not express any kind of meaning. As Bangla is a largely used language, almost 210 million people worldwide use this language, and it is also scored the 7th in position for the languages used globally. Bangla is a language with a complex structure and grammar, so actually detecting the errors and correcting them is a bit complex in a process in itself. So we have tried to make this work a context-sensitive work, and when we were researching and reading throughout other works that were done on this section, on this sector, we found that most of the works were context agnostic, not context sensitive, because it's easier to correct the errors when it's not context sensitive. And also the accuracy for the works of context agnostic works are better because the correction process is more simpler. So if we just look back to our previous work, in that work, what we did was firstly find the error while using the direct dictionary lookup method, and after identifying the error, we used the minimum edit distance and n-gram probability to get a correction prediction. So in those cases, the minimum edit distance algorithm was used to identify similarly structured words and then use the n-gram probability for the context sensitive portion of the work. I will describe the process more in our experimentation section. So after that, after gaining a probable candidate for the correction, we then calculated a linear accuracy, and the accuracy assessed from that work was 87.58%. Another thing to mention here is in such cases of works, it needs a huge amount of data and a huge amount of training cases and test cases. So in our previous work, we used a corpus of 3.7 million words. So if I briefly mention the improvements we made in our work, it's that firstly, in our previous work, we only got one possible correction for the identified errored word. And in this work, we tried to gain a list of possible corrections. And so it actually helps to increase the accuracy of our work because when we were only getting one suggestion, it was not always the correct answer. So it hugely decreased our accuracy. But now that we are generating a list of possible corrections, it actually if the first word of the list is not the correct word, the correct candidate, the possibility of the second word being correct is becomes higher. So it overall increases the accuracy of our work. And after that, we have transition from linear accuracy to frictional accuracy, which calculates the accuracy of our works with more precision and more sophisticatedly. Along with that, in this work, we also calculated the failure rate of the words in the suggested correction word list that also helps us to generate the possible correction words list accuracy more. And also, as I have mentioned before, that for such works, a huge amount of data is necessary. So to get more accurate predictions, in this work, we have increased the size of our corpus from 3.7 million to 10 million word count. So our experimentation was done in 3 stages mainly. And in the first stage, it was a lot similar to our previous work with detected the error word using the direct dictionary lookup method. As the error we are working with are non-word errors, that means the words that have spelling mistakes. So through direct dictionary lookup method, it was really easy to detect all of them. And then we applied the edit distance and n-gram algorithms. In this work, we have used 6 language models of n-gram, the bigram, trigram, hybrid bigram, hybrid trigram, backward bigram, and backward trigram. So at the end of this work, we have also make a conclusion on which of these language models gave us the best optimal solution for our problems. So when we are applying the edit distance algorithm, we are predicting the minimum edit distance, which focuses on making a set of words that are generating a set of words that are similar in structure with the word that with the errored word. And then what the n-gram language models do is that they take the set of words that was generated from edit distance and then compare them with the other words of the sentence and then find a possible solution and list up the possible solutions to get the correct word with respect to the context of that sentence. And after doing so, for our convenience, when we were running the program, for our convenience, we set the number of words in the list to 5. And because of that, when we were doing the test cases, what we found that as the number of words in the word list go higher, the accuracy for the
To interrupt
model
you, ma'am,
also.
but you have 2 minutes to conclude your presentation.
Yeah. Okay, thank you. So the accuracy for the model also goes higher. Then we calculated the frictional accuracy through the formula shown. And what we found was the results we gained from the previous stage and this stage were very similar. And the performance of the language models were also very similar. So I would like to mention one thing here, that the work of a context-sensitive as it is a context-sensitive work, depending on the number of words in a sentence, the result of accuracy and failure rate for the word and the prediction list changes, because the more words the algorithm gets to compare and determine the possible corrections, the error word generation becomes, the predicted word generation list becomes more accurate. And then we also calculated the failure rate, and when we calculated the failure rates, it gave us a complete contrast of the result from the accuracy rate we had calculated in our second stage. And where the accuracy was higher, the failure was less, the failure rate was less, and where the accuracy was less, the failure rate of that language model was higher. So after conducting all three stages, the language models that performed the best in all three stages were bigram, trigram, and backward bigram. But we chose to mention these three models because the difference in value among them were very less. But even though the difference in value of those models were very less, the bigram had the best results in all three stages. So we came to the conclusion that for this work, for our process, the bigram model is the best model to go with. So after averaging all the accuracies, we came up that our previous work gave us the accuracy of 87%, whereas the average accuracy for this work is 94%, which is considerably high for compared to the other works done in the same field. This is as I have said, this is the second stage of the work we are conducting. In the future, we plan to make another work that will work with real-world errors. That means the errors that, the words that are meaningful in itself, but it don't go with the context of a sentence. So that will be all for my presentation. Thank you so much.
Thank you so much, ma'am, for your presentation. Sir, do you have any questions?
So please let me know I'm spelling your name correct. Rehnuma.
Yes, sir.
So it was a good presentation from your side. So could you please let me know about the unique challenges for developing an autocorrect system for Bangla compared to other languages?
The main challenge for developing an autocorrect system in Bangla is that Bangla language grammar is very complex. When we have in the vowels and the signs are very similar, and also you can express one single sentence or one single word with different types of expressions. So which actually makes it very challenging to understand if the set of words that was used in a sentence is correct for the context. So the main challenge is matching the corrected word with the context.
Okay, so are you pursuing your PhD or MTech?
I am not, I'm currently taking a break, but from next year I will continue my master's.
Okay, so any research scholar or PhD guide is there in this research work?
Yes, I have been working with my professor from my university, Dr. Tarek Habib.
Is he associated with this research work? Have you
Yes.
mentioned his name?
Yes, I have mentioned his name in the author's slide.
What is the name?
It's MD Tarek Habib, Independent
Tariq Habib.
University. Yes.
And he is working on Bangla language.
Yes,
Sort of
sir.
thing. Okay. Good work. All the best.
Thank you, sir.
Thank you so much for your presentation. So we'll be moving on to the next presentation. Next up, we have Ruxana to present her paper titled Determinants of E-commerce of SMEs, a bibliometric analysis. Are you there, ma'am? Okay. So we'll be moving on to the next presentation. Next, we have Meera to present her paper titled Integrating Dual Signographic Techniques in Voice over Protocol Communication.
So I am the paper. Other authors, who is my guide and guide. So these are the topics we are going to discuss today. First is introduction, steganography on VoIP, problem statement, implementation, result, and reference. First of all, what is network steganography? Network steganography is a way to hide data within the network traffic. And network steganography is divided into mainly two parts, intra-protocol and inter-protocol. And my project consists in intra-protocol, which is of a hybrid technique. So next, about VoIP, actually, we all know that it is a real-time service, and we are enabling users to make call through data networks. So mainly, the VoIP has two main phases. First one is signaling phase. In that, we are negotiating connection parameters between the calling parties. And second one is a conversation phase, where we start our conversation. And the main protocol will be used as RTK protocol. So the protocols on the are SIPs, which is used for the connections between calling parties. Second one is start communication. We are using RTK protocol. Next one is codecs we are using, so that it will compress and decompress our voice data. Last one is that RTCP, which is a control protocol. It is used to control the communications over the sender and the receiver. So in my paper, I am discussing about mainly two steganographic techniques. Over that, first one is lag steganography, which means lost audio packet steganography. In this, we are purposely delaying a packet for a particular time. After that time expires, we are sending that to the receiver, so that receiver knows that our secret is in the delayed packets. So this is the communication that you can see here. One N4 packet is delayed for a particular time, and after that time, N4 is sent to the receiver. If the receiver knows that N4 has a secret, they are using it for the extraction purpose. Otherwise, they are ignoring that, and that packet will be lost. So next techniques we are using is that LSB embedding. In the LSB embedding, I'm taking its variations also to LSB, 3 LSB and all, 4 LSB and all. So for LSB embedding means we are embedding in the least rightmost bit. So in 2 LSB, we are embedding in the least rightmost bit. And in 3 LSB, we are embedding in the 3 rightmost least bit. So these are my problem statement. But first is that I'm creating a new embedding scheme that combines lag steganography features and the LSB-based steganography variants. Next, we are performing an analysis on the different parameters for the above scheme to differentiate the difference of of different variants. So this is my setup. First, I have created a VoIP communication using an IP tunnel for the secure communication between sender and the receiver. Since the method is requesting, both the sender and the receiver will work as a peer-to-peer communication. After setting the pods and making that pods available, we are making a call using an open source VoIP calls. And when Alice makes a call to Bob, there will be an invitation message like this, invite message. And when the Bob is accepting the call, the communication begins, and the lag technique is embedded into as an injector. So in the lag techniques, what we are doing is that first we are checking the packet sequence number and multiplying it with the prime number modulo, and checking it with the packet rate, whether it is zero or not. If it is true, we are going to next condition, that whether any packet is there to embed. If there is a packet, we are determining the length of the packet, payloads, and minimum payloads required to embed the data. And after that, ensuring their packet payload is large enough to embed the new data. We are packing the data using a format which is mainly used as a struct pack format in Python. By packing this, we'll get a new data. For this new data, we are creating a new delayed packets in which we are copying the original packets data, but we are replacing the payload of the delayed packet with the modified new data. After that, we will set a verdict to drop that original packet so that only the delayed packet is moved forward. And we are giving a timer so that after that timer, the packet is sent. For the calculation, for the extraction, first we will calculate the difference between the current packet timestamp and the previous packet timestamp, and will update the previous packet timestamp. And if the time difference is negative and its absolute value is greater than threshold value, we'll know that the delayed packet is arrived, and we'll retrieve the package payload from that by unpacking the data using the unpack format. For LSB technique also, we are following the same pattern, but we are adding an LSB technique on above the lag technique. So first we are checking the packet sequence number multiplied by prime number modulo rate is equal to 0. If it is 0, we are checking for the pending data where data is available to embed data. Then we are determining the length, and if your length is greater, we are continuing the process. Next, we will format the packet as previous. After that formatting, we'll create a buffer to save the new payloads which we have packed before. And this new payload is passed to a modify bit function. Modify bit function, I'll explain in a while. After that, we'll create a new delayed packet, and we'll replace that old original data with that modified data, and we are setting a timer and we are sending it to the receiver. And similarly, for extraction, the receiver will calculate different timestamps, and they will update the timestamp. And if it is negative and it is not values exceed the threshold value, it indicates the arrival of a delayed packet. And we'll retrieve the payload of the packet. We'll calculate the header, and the buffer is also created for the and a recovered bit function is called to extract the modified bits. After that, we'll unpack the data as it is for the previous method we have done. So in modify bit, what we are doing is that we will have a message, we'll have a medium, and we'll have a size corresponding to it. And bit per byte, in that what it is meaning that if we are doing for 8-bit, we are considering bit per byte as 8 bits to modify. After that, if the message size is able to hold the capacity of the medium and the bit per byte, we'll initialize the message and medium index to 0, and we'll retrieve the current bit from the message. After that, we'll insert the number of bits that we need to embed. If it is 8-bit, we'll insert 8-bit from we'll replace the 8-bit from the previous message, and we'll continue this until all the messages embedded. For extraction also, we are doing similar thing, but except that after we'll checking that medium size, whether it is perfect to fix in our fix our messages. we are extracting LSB from that medium using a bit and wise operator. After that, we are storing that extracted bit in the current bit of message using bit or wise operation. After that, we are doing it for every bit until the message is completely extracted. These are the result of first lab techniques. So as you can see, this is an format which we cannot understand. But when we are checking the similarity of the text, embedding and extraction, after that both the same text is identical. Similarly, for LAC also, we are checking the embedding and extraction. Both are same. For 2 LSB and 1 LSB also, I have checked. This is both same. So when I'm taking the length, length after embedding and after extraction is same. And for more verification of this purpose, I have done an analysis mainly of four tests. First one is packet loss rate, capacity, mean square, opinion square, and fourth one is jitter. Packet loss rate is the failure of a transmitted packet to reach the destination. Capacity, maximum amount of data that can be embedded, and means opinion square, it is used to check about the quality of the voice, and jitter is a delay in the packet arrival. In this table, we can see that Mo square is increasing as the bits are increasing. The bits are decreasing, rest of them are increasing as the bits are increasing. So from this, we can make a conclusion that 8-bit LSB embedding has an high packet rate loss and jitter compared to other embeddings. This means 8 bits have more degraded voice than rest of others. Next one, from this MOS, we can see that 1-bit LSB has a higher MOS square. So since the value is above 4, it will be having excellent quality. And capacity also increases as the number of bits increasing. So therefore, 8-bit LSB with the LAC technique has a more embedding capacity. So this is what my dissertation and my paper is on.
Thank you so much for your presentation, ma'am. Sir, do you have any questions?
Yes, only one.
Yes, sir.
So Meera, could you please explain me how does the integration of these technique impact voice or internet protocol performance and user experience?
Hello, sir.
Am I audible?
Yes, sir. Hello. Sir,
How does the integration of these technique impact VoIP performance and user experience? This is my question.
Sir, while doing this different techniques, when we are giving more embedding bits, actually what happened, we are integrating two techniques, LAC and ISBM. So interactivity is one of the main purpose we have taken care, so that more techniques are involved, so that detectability and breaking of the secret is more difficult. And in performance wise, while using less number of bits, it has more impact on, it has less impact on voice. The voice is not disturbed. So if we are sender and receiver is, when an outside is listening to it, if it is a one bit embedding technique, they cannot identify whether we have embedded a secret because there is no much variations in the voice qualities.
Okay. Thank you.
Thank you.
Thank you so much for the presentation, ma'am. So we'll be moving on to the next presentation. Next, we have Savita Sawant to present a paper titled Survey of Recent Approaches in Ontology Matching. Are you there, ma'am? Are you there, ma'am? Next, we have Javed Sheikh to present his paper titled Traffic Management Using Intelligent Transportation System Based on Vehicular Ad hoc Networks. Are you there, sir? Are you there, sir? Do we have D.K. Chaturvedi to present his paper? Do we have Ruxana Banu to present her paper? Okay. So I would like to sincerely thank our authors for their excellent presentations and contribution in the session, and all our participants for being a part of this international conference. I hope this session was informative enough for each one of you. We, on the behalf of the whole team, thank you for your support during this third version and all the previous two versions of the conference. We will be happy to have you in the fourth version in 2025 as well. Other presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to the printer. The publication will be live within 6 months, so kindly cooperate with the team of ISBM 2024. I would also like to take a moment to thank our session chair, Dr. Sunil Kumar Jhangir, for chairing this session. So this is a token of appreciation to the chair on the behalf of the whole team of ISBM 2024 and Global Knowledge Research Foundations and partners. Thank you so much, sir, for your valuable presence. Would you like to share a quick closing remark with us?
Thank you, Anshika and Parth, for organizing this online session. I hope they were managed to presenter, but that's not the case. Everyone has different time span and different probability. So I would like to thank organizers, convey my sincere regard to Amit Joshi and Mihir Chauhan, and look forward for being this session in future as well.
Thank you for your valuable presence, sir. I would request
And,
everyone to
and
please.
there is one suggestion from my side in this particular certificate. If you can change one thing,
Yes, sir.
could you please show again?
Yes, yeah, sure. Sir. I'll show you again.
Like currently, I'm not in any organization of educational organization, we can say. I'm working as a senior manager. So instead of Professor Sunil Kumar Jangid, you can write Dr. Sunil Kumar Jangid only.
Sure, sir. We'll make the changes.
Okay. Thank you. So nice of you. All the best. Thank you. Thank you.
Can I request everyone to please turn on their cameras for a quick snapshot?
Yes.
Thank you so much, everyone, for your valuable presence. Looking forward to seeing you all again. Thank you.